Yes, hi guys. So we are continuing from question number 5 is completed. Now answer of it was 3 pi a square upon 4. Same question we have obtained 3 upon 4 pi a square. Alright, we have to prove this. This was the area between this point, okay, and this is the asymptotes of it. It says that find the area. Question was show that the area bounded by the seesaw, this is known as seesaw shape of the cusp type and having asymptotes here. So this is seesaw type of cusp, okay, and where all these things we have applied here. So finally answer is obtained as this. The same answer is obtained 3 upon 4 pi a square is proved. Okay, so now let me take the last question of this exercise. Okay, these questions. Next question, which is the last one. Let me describe that in detail. Okay, so that this whole exercise is understood in nutshell. Now let me talk about question number 6. Question number 6 is of what kind? Let me check it. Okay, and from that very question I will tell you that how to trace a curve, how to find the shape of the curve. Now, question number 6 says, find the whole area of the curve given by whole area of the curve by the curve given by the equations this one. Whole area of the curve given by, this is whole area of the curve given by whole area of the curve, this is curve given by the equations this and this. Okay, this is the question here. Find the whole area of the curve given by the equations this and this. Okay, or this is the shape of the same, these parametric equations in Cartesian form. So let me just obtain first that how this Cartesian form is obtained. Let me now discuss about this. So parametric forms of these equations, the parametric forms of these equations are here. What is that? X equal to x equal to a cos qt, alright, and y is equal to b sin qt. Okay, these are the parametric forms, parametric equation which we are discussing here, and how to find the area of a curve traced by parametric equations. Okay, so there are two methods which we have discussed. That first is parameter elimination method. This is an elimination method. Second, if we are not able to eliminate the parameter, then second method is by finding derivative or differentiation. Okay, finding d by dx by differentiating both the equations of x and y with respect to t, the variable here, so parameter here. Sometimes it is theta, sometimes it is phi. So with respect to that parameter given, we have to differentiate that. So find d by dx. In that situation, we have to eliminate this. So first method is elimination method, second method is derivation method. So in this case, we will find out. Let me use the first method because here elimination method can be used. Let me form the equation here. Okay, so solution. Now let me transform this equation. Transforming these equations, we change the marker. Okay, these equations into Cartesian form, into Cartesians or Cartesian form, into Cartesian form. Okay, what we will do? We are given here x is equal to a cos qt, or x upon a is equal to cos qt, or we can find cos t is equal to, or let me write here, cos t is equal to x upon a whole power 1 upon 3. Now if I find the square of this is the first, okay, let me squaring that, or cos square t, if I square it, then it will be x upon a whole power 2 by 3, because squaring 2 upon 3, that will be 2 by 3, this is cos square t. Similarly, of the second equation, y upon b is equal to sin square t, qt, or y upon b whole 1 upon 3 equal to sin t, or sin square t, squaring it, sin square t is equal to y upon b whole power 2 by 3. Now if I add, this is, let me take third equation, this is first, this is second one, and this is the third one, and this is the fourth one. If I add first and second, sorry, third and fourth, so adding on addition of third and fourth, we get sin square theta sin square t plus cos square t is equal to these values, that is x upon a whole 2 by 3 plus y upon b whole 2 by 3. Okay, this is 1. So 1 is equal to x upon a 2 upon 3 plus y upon b 2 upon 3. Now this is the same equation which we have obtained here, Cartesian form. So that's why this is, it has been written either okay, find the area of these curves, parametric forms, or this Cartesian form. So Cartesian form is obtained from the same equations of parametric. So question is same, I mean either this form or this form. So now let me solve this form. Now this form is known as hypocycloid form. This is known as hypocycloid form. This is a hypocycloid form. Okay, hypocycloid form. Now let me solve this question. First let me trace this, what kind of figure is coming out, and let me just trace it first. So equation we have obtained, x upon a whole power 2 by 3 plus y upon b whole 2 by 3 is equal to 1. So what is the shape of the curve? Let me talk about that. Because this tracing of the curve we have done in, I think, lecture series 79, and question was maybe 11, 12 or something. So please see my lecture 79 series in which curve tracing I have done. There I have discussed this whole hypocycloid shape of the curve. So this is hypocycloid shape, known as hypocycloid shape of the curve. Now let me find out the curve. How to trace the curve, then I'll find out the area finally. So first let me trace this. What kind of this tracing is? Here this curve will be, this curve is symmetric. Is symmetric about both the axes. About both the axes. Why? Because this is whole square. Let me write this, or x square upon a square whole power 1 upon 3 plus y square upon b square whole power 1 upon 3 is equal to 1. We can write like this. This is whole square, even, okay, even powered. Both the variables are even powered. Because of that, the curve is symmetric about both the axes. Second point. Now this curve will not pass through the origin. The curve will not pass through the origin. Why? Because independent term 1 is there. Constant independent term, which is here 1. The curve will not pass through the origin. Not pass through the origin. As 1 is a constant independent term. Constant independent term is present here. Constant independent term is present here. Alright. This is the one thing. Next thing, let me discuss that what is that. Then points where the curve will meet x-axis and y-axis. Let me now putting third point. Putting y equal to 0. If y 0, then x square upon a square whole 1 upon 3 is equal to 1, or x square upon a square is equal to 1. Because q root of 1 is also, sorry, q of 1 is, we have to cube on both the sides. So this is 1, or this implies that x square equal to a square, or x equal to plus minus a. So what are the points on the x-axis where the curve meets the x-axis at point a0 minus a0. Okay, so curve will meet the x-axis at a0 and minus a0 points. Next point, similarly we can say, okay, the curve will meet the y-axis at, because y will also be equal to plus minus b, because if I put x equal to 0, then y square upon b square whole 1.3 equal to 1, or y equal to b square, y square equal to b square, or y equal to plus minus b. That means 0 and b and 0 and minus b. This is on the y-axis. The curve will meet the y-axis at these 2 points, 0b and 0 minus b. And at x-axis a0 and minus a0, the curve is of this kind. Secondly, let me find dy dx of this, so that we can find that what is the okay, the tangent at these points a0. Let me find a0 and 0b. First let me find these 2 points here. Okay, so what is the dy dx here? If I differentiate this, differentiating it with respect to x, dy dx we have to find out. It will be 2 by 3 into x upon a whole power 1 upon 3 left over minus 1. Why? Because 2 by 3 power will come before differentiation, and this is minus 1.3 power left over, because 2 by 3 minus 1, that means 2 minus 3 upon 3, that means minus 1.3 left over, plus similarly here 2 upon 3 by upon b. Okay, and this will be into 1 upon a also. I'm sorry, for this x upon a is again differentiated, 1 upon a will be multiplied. Here by upon b 1.3, then coefficient of by is 1 upon b into d by dx also equal to 0. What is that? D by dx, therefore this dy dx equal to minus sign. Okay, so it will be b, this is b raised power, but b and b raised power minus 1.3 is b square here, or let me write here, this is b raised power minus 1.3 plus 1, that means 2 by 3. So b raised power 2 by 3 will come in the numerator here, but this is in the denominator by raised power minus 1.3, so it will come in the numerator positive value. Whereas similarly here a 2 by 3 cancelled out. Okay, and this is also a raised power 2 by 3 into x raised power 1.3. So this is the value of dy dx. What is that? Minus b raised power 2 by 3, y 1.3, and a raised power 2 by 3, x raised power 1.3. Now, if I find that what is the tangent, dy dx is tangent value, or the slope of the curve, okay, or the tangent will meet the curve at this point A0. So at A0, d by dx is what? D by dx at A0 is equal to, if I put A0 means x equal to A and y is 0, so it is 0. It means the tangent makes 0 angle at point A0. Okay, here let me talk about tangent at A0. Tangent at A0, or the slope of the tangent at A0 is at A0 is 0 degree, is 0, or it is along the x-axis, or it is along the x-axis, Similarly, at 0b, if I find out 0b, okay, dy dx at 0b, and at 0b, dy dx at 0b, what is the slope of the tangent at 0b point? This is minus sign, minus b raised to 2 by 3, by is here b raised to 1.3 divided by x is 0. This is 0 here, denominator 0. It is infinity, minus infinity. It means the tangent at 0b point makes 90 degree angle, because tan 90, tan theta is equal to, this is minus alpha, sorry, minus infinity, this is minus infinity. That means tan minus pi by 2. Okay, so that means at the point 0b, the slope is, the tangent is at 90 degree. So let me find out what is the shape of the curve here. So the curve is of this kind. The curve is of, sorry, the curve is of this kind. Okay, this is y-axis, y dash axis, x-axis, x dash axis is origin O. Now the slope we see here at A0, the slope is along the 0 axis, because 0 angle is made by the tangent at this point. So tangent is x-axis only. So at this 0 degree angle is there, and at this is y-axis here. So y-axis makes 90 degree angle. So it is 90 degree angle. So tangent theta equal to pi by 2, sorry, tan pi by 2, or theta equal to, let me take theta angle. Theta is pi by 2 here. The angle made by tangent at this point is 0b point here. Here it is 0 minus b. Here it is minus a0. So this is the slope of the curve. But the area we have to find out. Area we have to find. Then let me take a strip here in the first quadrant, and the whole area will be 4 times of this. This is suppose O. Let me take A. This is B point. This is B dash point. This is A dash point. Okay, so area OAB 4 times of this. So therefore, we have to find out the area included by this curve. Therefore, area let me find out finally. So finally, this is the tracing of the curve we have done. This is the hypocycloid shape. Okay, and what is the area of this curve? Let me find out that. Therefore, required area. Therefore, required area of the curve, hypocycloid curve. This is hypocycloid. Sorry, CYCLOID. This is hypocycloid. Hypocycloid curve. This shape is known as hypocycloid. Okay, here it is 90 degree angle, and tangent makes an 0 degree. So this is along the x-axis, here along the y-axis. Again, here it is along the x-axis, but in this side. Okay, so let me take area. This is area equal to 4 times into area OAB. OAB, this area. Now this is, let me take PQRS, and distance between these two is this is dx here. Area is given by 4, sign of integration. Here it is 0 to a. X limits of x variable. But here we have to take dx here. So this is y into dx. Okay. It can be written as y. What are the limits for? Y is here. This, but x coordinate, because x limits are given here. If I take x 0, a 0, 0 upon a 0, cos qt equal to 0, that means cos equal to pi by 2. Here, at x equal to 0, okay, cos qt equal to 0, or cos t equal to 0, that means cos pi by 2, cos 90 degree. Cos 90 degree is 0, so therefore t equal to pi by 2. Lower limit is pi by 2. Try to understand it 0. When x is 0, then t is pi by 2. Because we have to convert this into parameter t now. Limits. Then at x equal to a, upper limit, at x equal to a, here it is a equal to cos q t from first equation is equal to a upon a, that means 1, but cos 1 is for cos 0 degree, therefore t equal to 0 degree. So here it is 0. Now y is given here b into sine, it is sine qt into it can be written as dx dt into dt. Okay, so now let me write what is the dx dt here. Dx dt, let me write here. So this is equal to 4 pi by 2 to 0, pi by 2 to 0. Okay, this is b into sine qt. Let me write, find here. What is value of dx dt? Dx dt. This is dx dt. So dx dt is equal to a cos qt is given. So differentiation will be minus sine 3 into a cos square t into cos square t is differentiated. Minus sign is now minus sign because cos t is differentiated, minus sine t into sine t. Minus sign I have already put. This is 3. First is 3 into a cos square t. Then cos t is differentiated. Cos t is minus sine t. So this is minus sine t. So value is minus. This value is into, okay, dt. For dx dt we have just differentiated with respect to t. Dx dt is this value. Okay, no problem. This we can write here, negative value minus 3a into cos square t sine t into dt. Dt is here already, dt. This is dt. Now let me rub this whole figure so that we can have the space. Now figure is understood to us. We have understood the figure, I mean. So this is dt here. Or let me solve it. This is minus sign. So minus sign, if minus sign is given, then we can interchange the limits. So limits, let me write here. This is 4 3 is 12. 12 a into b, okay. Positive 12 ab. I have interchanged the limits now. It is pi by 2 to 0. It will become 0 to pi by 2. Negative sign is eliminated now. Because element, if minus sign is there, negative sign is there, we can interchange the limits. This is definite rule, definite integral rule. Rule for definite integrals. That whenever limits is negative, if negative sign is given here, then we interchange the limits. So limits are interchanged. And this is plus 12 ab. 4 3 are 12. b into a, that means 12ab. Now sine qt or sine t, that means sine 4t power 4 into cos square t into dt. Okay, this is the value left over. b sine qt, and this is sine t after differentiation. Sine t into sine qt, sine 4t, power is 4, and this is now cos square t left over, cos square t. Now we have to integrate this with the help of beta gamma function or gamma function. So what does gamma function say? Since we know that formula 0 to pi by 2, if limits are there, and it is sine raised to power m, let me take m theta into cos raised to power n theta d theta, then the gamma function definition says, then it will be gamma m plus 1 upon 2 gamma n plus 1 upon 2 divided by twice gamma m plus n plus 2 upon 2. This is the formula from gamma function we know about. The same formula we will apply here. Let me find that what is the final answer of this question. So this answer 12ab, the required area, therefore we are finding out the required area of the curve or under the curve, okay, of the curve under it. Whole area we have to find out. This is equal to 12ab, 12a into b, this is 12ab into, now this is 4, so 4 plus 1 upon 5, that means 5 upon 2 gamma 5 upon 2, because 4 plus 1 upon 2, 5 upon 2, gamma 2 plus 1, 3 upon 2, divided by twice gamma 4 plus 2, 6 plus 2, 8, 8 upon 2. Okay, 4 plus 2, that means 8. 4 plus 2, 6, 6 plus 2, 8, 8 upon 2. This is the final value, but let me solve it further. What is the final answer of this question? So let me rub this. Therefore, final value of this, let me solve it. So 12ab, this is 12a into b, okay, and then gamma 5 by 2, we know that this is 3 by 2 into gamma 1.2, because whatever is this 5 by 2 gamma, suppose, then we write minus 1, 5 by 2 minus 1 is what? That will be here. So 3 by 2 into gamma, then 1 less further, 3 by 2 minus 1, that means 1.2 left over, and then gamma 1.2. Finally we write gamma 1.2, okay, into 3 by 2 is minus 1 first, so that means 3 by 2 minus 1 is 1.2, first 1.2, then gamma 1.2 left over. We write like this, since let me write here gamma n upon 2 equal to n minus 1 upon 2 gamma. This is the formula here, or sorry, not this one, n minus 2 it will be, but we have to write here n minus 1 like this. It will be n minus 2 upon 2 into gamma n minus 2 upon 2. This is further extended. This is n minus 1 means n minus 2 here. Let me write, this is n minus 2 upon 2. How we have obtained n minus 2? After subtracting 1. N minus 2 minus 1, that means n minus 2 upon 2. This is the formula here. Since we know gamma n by 2 is equal to n minus 2 upon 2 gamma n minus 2. N minus 2 upon 2 comes out of the gamma sign. Okay, so similarly here, but this is 2 into gamma 4. Now gamma 4 is factorial 3. Note gamma n equal to factorial n minus 1. 1 lesser than this and then factorial. The same value will be obtained. Why? Because this n is equal to n minus 1 into gamma n minus 2. So n minus 2, n minus 3 and so on, n minus 1. So this is n minus 1 factorial. Simple. Therefore, factorial for gamma 4 is factorial 3. Simply, gamma 4 is factorial 3. Let me write here. This is 12ab into 3 upon 4. 3 upon 2 to the 4 to the 8. 3 upon 8 in the numerator. Gamma 1.2 is equal to square root pi. Since this, therefore, this is square root pi is 2 to the 4 to the 8, 3 upon 8 in the numerator. This is root pi, square root pi into square root pi. Gamma 1.2 is divided by 2 into factorial 3. 2 into factorial 3. Sorry, 3 factorial. Because gamma n equal to gamma n minus factorial n minus 1. That means 4 is gamma 4 is factorial 3. Simple. 1 lesser than the gamma value. That is into factorial. So this is 3 upon 8 means 3 to the 16 here. Let me write first 3 into pi. Square root pi into square root pi is pi. Divided by 8 into 2. Factorial 3 is 3 into 2 into 1. Factorial 3. Finally, what do we get here? 2 3 is 6 to the 12. So this 12 cancel out. Okay, so this is equal to 3 into pi into a into b in the numerator 3 pi ab divided by 8. Okay, this is the final answer. 3 pi ab, 3 into pi into ab upon 8. This is the final answer. This question has taken time, but it is true. Question is 100% true here because this is a process. The same process we have to apply in each question. Those questions I took very hurriedly, but undoubtedly those questions can be done in the same fashion. The last question is lengthier one. Just taken more time. The first one was also lengthy. First and last one, they are very lengthy questions. Okay, so this is what we have done. So this is now completed. Next, in the next video, now I will take polar coordinates or polar equations. When equations are in the polar form, then how we transform them will be